Imagine stepping into a forest so vast that no matter how far you walk, the trees keep going, no edge, no boundary, just endless paths stretching into the unknown. You pass the same kind of moss-covered oaks, hear the same rustle in the underbrush, and feel the same soft earth beneath your feet, yet nothing changes. No clearing appears. No mountain ridge marks the horizon. You begin to wonder, did I ever truly enter this forest? Or has it always been here, surrounding me, infinite in every direction? Now, let that forest become the universe. Not just large, not just expansive, but truly endless, without edge, without boundary, without end. This is the first mystery we drift into, the possibility that the universe may never end. For thousands of years, humans have looked up at the night sky and asked, what lies beyond? Is there a wall at the edge of everything? A curtain drawn across the cosmos? Ancient myths spoke of great serpents coiled around the world or gods holding up the dome of the sky. These were attempts to give shape to the shapeless, to place a limit on the limitless. But as our understanding deepened, we began to suspect something far stranger, that there may be no edge at all. Not because we haven't traveled far enough, but because the universe, by its very nature, might not allow for one. Modern cosmology, built upon Einstein's theory of general relativity and decades of astronomical observation, suggests two radical possibilities. The first is that the universe is infinite, truly, mathematically endless. No matter how far you travel, in any direction, space continues. There is no final star, no last galaxy, no border between the cosmos and nothingness. The second possibility is even more subtle. The universe might be finite, but unbounded. Like the surface of a balloon, it has a measurable size, yet no edge. If you were to travel in a straight line across such a cosmos, you would eventually return to where you began, not because you turned around, but because space itself curves back on itself. There is no outside to fall off of. The universe, in this model, contains all there is. How do we know which is true? Scientists measure the geometry of space by observing the cosmic microwave background, the faint afterglow of the Big Bang. By analyzing tiny fluctuations in this radiation, they can determine whether space is flat, curved like a sphere, or curved like a saddle. Current data strongly suggests the universe is flat, or very nearly so. In a flat universe, parallel lines never meet, triangles have angles that add up to 180 degrees, and space extends infinitely in all directions unless something stops it. And so far, nothing has. But what does infinity really mean? It's not just a very big number. Infinity is not a destination, it's a concept that defies completion. It means that no matter how far you go, there is always more. And if the universe is infinite, then something extraordinary follows. Every possible arrangement of matter must occur somewhere. Not just once, but infinitely many times. Somewhere, in the vastness beyond our horizon, there may be another Earth, orbiting another sun, with another version of you, reading these same words, feeling the same breath in their chest, hearing the same quiet hum of the night. Not because of magic, but because in an infinite space, randomness repeats itself. Given enough room, even the most unlikely combinations will emerge. You are not unique in the cosmos, not if infinity is real. This idea can feel unsettling. It challenges our sense of individuality, of meaning. If there are infinite versions of you, making every possible choice, living every possible life, then what does it matter what this version does? But perhaps the opposite is true. Perhaps the infinite makes the present more precious. This moment, this breath, this thought, this stillness is real. It is happening. And while other versions of you may exist, only this you is here, now, listening, wondering, drifting towards sleep. And yet, we must ask, can the universe truly be infinite? Our minds recoil at the idea. We evolved to understand boundaries, to know the edge of the cliff, the border of the tribe, the limit of the known world. Infinity offers no such comfort. It is boundless, relentless, silent. There is no vantage point from which to see the whole. No map that can contain it. Even light, the fastest traveler in existence, has only reached a finite distance since the beginning of time. We are trapped within a bubble of observable universe, about 93 billion light-years across, surrounded by darkness we may never penetrate. But here's the deeper mystery: if the universe has no edge, then it also has no center. Not in the way we think of centers. There is no cosmic capital, no heart of all things. Every point is equally central. From any galaxy, it appears as though everything is moving away, like dots on an inflating balloon, each seeing the others drift apart. The universe doesn't expand into anything. It simply is, growing larger from within. There is no outside. No beyond. Just existence, unfolding. Take a moment now to imagine standing on the edge of reality, and finding there is no edge. Just silence. Just space. Just more. No wall. No door. No final frontier. Only the quiet hum of stars forming and dying, galaxies spinning in the dark, and the endless stretch of void where no light has yet traveled. You are not at the center. You are not at the edge. You are simply here, floating in a moment of awareness, in a universe that may go on forever. And if space has no end, what about time? Could time itself stretch infinitely, endlessly forward, and perhaps even backward? Could it bend, twist, or loop in ways we can't perceive? The nature of space has unsettled our sense of place. But time may unsettle our sense of self. Let us now drift gently into the next mystery, the fluid, fragile nature of time, and how it may not be as fixed as it seems. You check your watch, pour a cup of tea, and feel the steady tick of moments passing. The steam rises in slow curls, the second hand advances with quiet precision, and you mark your place in time as if it were a straight, unbroken line stretching from yesterday into tomorrow. This is how we live, anchored in the rhythm of clocks, calendars, and routines. But what if I told you that time doesn't flow the same for everyone? That your now might not be someone else's now? That the cup of tea cooling in your hand is aging at a different rate than an identical cup floating in deep space? Time, as it turns out, is not the rigid, universal constant we assume it to be. It is fluid, malleable, and deeply personal, woven into the very fabric of space in ways that defy intuition. For centuries, time was thought to be absolute, a single, unchanging backdrop against which the events of the universe unfolded. Isaac Newton envisioned it as a great river, flowing at the same rate for all, everywhere. But in 1905, Albert Einstein shattered that picture with his theory of special relativity. He showed that time is not separate from space, but part of a unified four-dimensional structure, space-time. And just as space can bend, so too can time. The faster you move through space, the slower you move through time. This isn't poetic metaphor, it's measurable fact. Atomic clocks flown on airplanes have been shown to run slightly slower than their counterparts on the ground. Satellites orbiting Earth experience time at a different rate than we do, and GPS systems must correct for this discrepancy every second, or they'd lead us astray by miles. Time dilation is not science fiction. It is built into the machinery of reality. Imagine two twins, one stays on Earth, the other boards a spacecraft traveling at nearly the speed of light to a distant star and back. When the traveler returns, They are younger than their sibling, perhaps by years, depending on how fast they went. From the traveler's perspective, time passed normally. They ate, slept, read, and watched the stars blur past. But from Earth's perspective, their clock ticked slower. Both experiences are true. There is no single correct time. Time is not a metronome set to one beat for all. It is a flexible rhythm, shaped by motion and gravity. And gravity, too, bends time. According to Einstein's general theory of relativity, massive objects like planets and stars warp the space-time around them. The stronger the gravity, the more time slows down. A clock at sea level runs slightly slower than one on a mountain top, where gravity is weaker. Near a black hole, where gravity is extreme, time stretches so thin that, from an outside observer's view, someone falling in would appear to freeze at the edge, never quite crossing over. Their seconds could be our centuries. In this way, time becomes a landscape, uneven, sloped, distorted by the weight of matter. This leads to one of the most unsettling implications, the idea of the block universe. Some physicists and philosophers suggest that past, present, and future all exist simultaneously, like frames on a film reel. In this view, time doesn't pass at all. Your birth, your childhood, this moment, and your death, all are already there, fixed in the geometry of space-time. What we experience as the flow of time is merely the movement of consciousness through this static structure. You are not moving through time, you are spread across it. The sensation of now is like a spotlight moving across a stage, illuminating one moment at a time, but the entire play has already been written. If this is true, then free will becomes a haunting question. Are we choosing our path, or simply experiencing a path already laid out? Are we authors, or readers of a story we can't change? Some find this idea cold, even terrifying. Others find it strangely comforting, the sense that nothing is truly lost, that every moment, no matter how fleeting, endures in the fabric of reality. And then there are the paradoxes. If time slows near a black hole, could someone falling and witness the entire future of the universe in the final moments before crossing the event horizon? From their perspective, time outside would appear to speed up, stars burning out, galaxies colliding, civilizations rising and vanishing in a flash. They would see the end of time before they even reach the singularity. Meanwhile, to an outside observer, they never fallen at all, just fade into redness, frozen in time. Close your eyes for a moment. Feel your breath. Inhale, exhale. Each breath marks a second passing. But somewhere, on a satellite orbiting Earth, time is moving just a fraction slower. Somewhere near the center of the galaxy, where stars crowd together in dense clusters, clocks tick at a different pace. A child on Mars would age imperceptibly faster than their twin on Earth. Time is not a shared river. It is 1,000 streams, each flowing at its own rate, shaped by speed, by gravity, by the invisible curves of space-time. And yet, we all live as if time is the same. We schedule meetings, remember birthdays, mourn lost years. We speak of wasting time or running out of time, as if it were a finite resource measured the same for everyone. But the deeper truth is far stranger. Time is personal. It belongs to you, shaped by where you are and how you move. Your now is not the universe's now. There is no universal present. The idea of now only makes sense locally. When you look at the stars, you're seeing their past. When someone on a distant planet looks at Earth, they see us as we were years ago. Simultaneity is an illusion. As you lie here, drifting, let this thought linger. Time is not passing. It simply is. And you, this version of you, in this moment, are a single slice of a much larger, silent, eternal structure. The past is not gone. The future is not unwritten. They are all here, somewhere in the geometry of the cosmos. And speaking of places where time bends beyond recognition, where gravity warps reality itself, let us now drift toward the edge of one of the universe's most mysterious objects, the black hole, where time doesn't just slow, it vanishes. In the quiet corners of space, where starlight grows thin and the darkness deepens beyond comprehension, invisible giants lurk, so dense, so gravitationally fierce, that not even light can escape their pull. These are black holes, not cosmic vacuums mindlessly devouring all, but enigmas wrapped in silence, places where the known laws of physics stretch to their breaking point and perhaps snap altogether. They are not holes at all, but concentrations of mass so extreme that they puncture the fabric of spacetime itself, creating regions where gravity wins over everything, over matter, over energy, over time. To approach one is to drift toward the edge of understanding, where science meets mystery, and certainty dissolves into wonder. Black holes are born in violence. When a massive star, many times heavier than our sun, burns through its nuclear fuel, it can no longer resist its own gravity. The outer layers collapse inward with unimaginable force, crushing the core into a point of infinite density, a singularity. This is not just dense matter, it is a place where the known laws of physics cease to apply. All that mass, perhaps several suns' worth, is compressed into a region smaller than a proton. Around this singularity forms the event horizon, the boundary beyond which nothing can return. Cross it, and you are severed from the rest of the universe. No signal, no light, no whisper of your existence can ever escape. It is the ultimate point of no return. For decades, black holes were thought to be utterly dark, silent, and eternal, cosmic dead ends. But in the 1970s, Stephen Hawking proposed a radical idea that changed everything. Black holes are not entirely black. They whisper. Near the event horizon, quantum fluctuations in the vacuum of space give rise to pairs of virtual particles, one falling into the black hole, the other escaping into space. To an outside observer, this escaping particle appears as a faint radiation, now known as Hawking radiation. It is not light from the black hole itself, but energy slowly leaking from its gravitational grip. Over immense stretches of time, trillions upon trillions of years, this process causes the black hole to lose mass and eventually evaporate, fading into nothingness like a dream at dawn. But this revelation brought with it a profound paradox, the black hole information paradox. In quantum mechanics, information, the complete description of every particle, its state, its history, can never be truly destroyed. It may be scrambled, hidden, or transformed, but it persists. Yet if a black hole evaporates completely, what happens to the information of everything that ever fell into it? Did it vanish? If so, then one of the most fundamental principles of physics is violated. But if the information remains, where is it? How could it escape? This question has haunted physicists for decades. Some propose that the information is not lost at all, but encoded on the surface of the event horizon, like a hologram, where a three-dimensional reality is stored in two dimensions. Every particle that ever crossed the threshold leaves a faint imprint, a kind of cosmic fingerprint, on the boundary itself. In this view, the interior of the black hole may be an illusion, a projection of data stored at its edge. The universe, in its most extreme corners, may be fundamentally holographic, a vast, intricate recording of everything that has ever been. Others go further, suggesting that black holes are not destroyers, but portals. That the singularity is not an end, but a bridge. Some theories, like those involving Einstein-Rosen bridges, propose that black holes could connect to white holes in distant regions of spacetime, or even to entirely separate universes. If you fell into a black hole, would you be crushed into nothingness, or flung into a new cosmos, reborn in a realm with different laws, different stars, a different version of reality? We cannot know. The equations allow for it, but observation fails us. The event horizon is a veil, and behind it, all is speculation. Imagine standing at the edge of a black hole, not too close, just near enough to feel its presence. The stars behind you would appear to warp and stretch, their light bent into glowing arcs by the immense gravity. Time itself would slow, as if the universe were breathing in slow motion. To a distant observer, you would seem to freeze, fading into redness, your image lingering at the horizon like a memory refusing to let go. But from your perspective, you would fall inward, crossing the threshold without noticing anything unusual at first. Then, the tidal forces would begin to pull, stretching you like taffy in a process aptly named spaghettification. And beyond that, silence. Darkness. The unknown. Yet even in their silence, black holes speak. They ripple space-time when they collide, sending gravitational waves across the cosmos, waves we have now detected, like echoes of cosmic thunder. They shape galaxies, anchoring the centers of vast star systems with their unseen gravity. They are not mere monsters, but architects of structure, sculptors of the large-scale universe. The more we learn, the more they seem less like destroyers and more like cosmic librarians, guardians of secrets written in the language of gravity and quantum fields. Pause for a moment. Let your breath slow. Imagine yourself floating near the event horizon, not falling, just watching. The stars smear into rings of light. Time stretches. The universe behind you ages and fast forward. And you wonder, if you stepped over that edge, would you vanish, or would you emerge somewhere else, in another reality, in another time? Is the black hole a tomb, or a doorway? As you rest in this quiet contemplation, remember that even the most terrifying mysteries of the cosmos are part of a larger pattern, the universe that balances destruction with creation, silence with whisper, darkness with the faint glow of Hawking radiation. And if black holes can warp space and time so completely, perhaps our most basic assumptions about location, about center and edge, are also illusions. In fact, the next idea might shatter your sense of cosmic location entirely, because the universe, it turns out, may have no center at all. We often imagine the universe like an explosion, a brilliant flash at the beginning of time, a single point in the void where everything erupted outward, like shrapnel from a cosmic grenade. Galaxies, stars, and planets flung into the dark, racing away from a central origin. It's a powerful image, one that feels intuitive. After all, every explosion we've ever seen has a center, a firework bursting in the sky, a bomb detonating on the ground. So naturally, we assume the universe must have one too. But what if that picture is wrong? What if there is no center? Not because we haven't found it yet, but because the universe, by its very nature, cannot have one? What if, in a quiet and profound way, everywhere is the center, and nowhere is? This is one of the most disorienting realizations in modern cosmology. The Big Bang was not an explosion in space. It was the rapid expansion of space itself. There was no pre-existing void into which the universe burst. There was no outside for it to expand into. Instead, space, time, energy, and matter all began together, and from that moment, space has been stretching, everywhere, all at once. To grasp this, imagine the surface of a balloon. On that surface, draw a few dots to represent galaxies. Now, slowly inflate the balloon. As it expands, each dot moves away from every other dot. No dot is at the center of the surface, Because the surface is two-dimensional, curved, and finite without edges. The center of the balloon exists, but it's not on the surface. It's in a dimension the dots cannot perceive. In the same way, if our universe is expanding like that balloon's surface, then every point in space sees all other points moving away. From Earth, it looks like galaxies are fleeing from us. But from a galaxy a billion light-years away, the view is identical. Everything is drifting apart, and they seem to be at the center. There is no privileged location, no cosmic capital, no origin point you could visit, no monument marking where it all began. The Big Bang happened everywhere, in the space where you now sit, in the void between distant stars, in the heart of ancient galaxies we'll never see. It wasn't a location. It was an event that filled all of space at the earliest moment we can describe. And because space itself is expanding, there is no edge to reach, no boundary to cross, and no center to find. The universe, in this sense, is profoundly democratic. It does not favor one place over another. It simply unfolds, uniformly, in all directions. This idea can feel unsettling at first. We are creatures of perspective, evolved to navigate a world where location matters, where here is distinct from there, where home is a fixed point, and journeys have destinations. But in the grand scale of the cosmos, that intuition fails. There is no cosmic map with a star marking the center. No coordinates to guide a spaceship to the origin of all things. Even if you could travel faster than light, faster than the expansion of space itself, you would never arrive at a place that feels like the beginning. Wherever you went, the universe would look roughly the same, galaxies receding in all directions, the same faint glow of the cosmic microwave background humming in every corner of the sky. You would always be, from your own vantage point, at the center of your observable universe. But so is everyone else. Picture yourself floating in deep space, far from any star, surrounded by darkness punctuated by distant galaxies. You look out in every direction, and you see those galaxies moving away from you, their light stretched red by the expansion of space. Now, teleport instantly to a galaxy on the opposite side of the cosmos. Look around. The same thing happens. Everything is moving away from you. You are once again at the center of your own cosmic horizon. This isn't an illusion. It's a consequence of how space grows, not from a point, but from all points simultaneously. The universe expands within itself, like dough rising in an oven, with every raisin moving away from every other, not because they're flying apart, but because the dough between them is stretching. This realization is both humbling and strangely liberating. It strips away any lingering sense of cosmic importance. Earth is not the center. The Milky Way is not the center. There is no throne at the heart of existence. We are not special in location, in position, in placement. And yet, in another way, we are everywhere. Because the conditions that gave rise to stars, planets, and life existed throughout the early universe, the same processes unfolded in countless places. We are not an anomaly confined to one privileged spot. We are part of a universal story, written in the same laws of physics, the same elements, the same stardust, repeated across billions of galaxies. Pause for a moment. Let your breath slow. Picture yourself not as a tiny speck in a vast void, but as a conscious node in an endless web of expansion. No matter where you are, the universe recedes from you in all directions. You are always at the center of your own experience, of your observations, your memories, your now. But in the grand scheme, you are also nowhere. Not because you don't matter, but because the universe doesn't measure value in coordinates. It simply is. Expanding. Stretching. Breathing. And if the structure of the universe defies our intuition, no center, no edge, no direction of out, then perhaps its very nature is even stranger than we think. What if the universe isn't just vast and centerless, but fundamentally unreal in the way we assume? What if everything we see, touch, and feel is not the deepest layer of reality, but a projection, a simulation, a dream coded into the fabric of existence? Let's now drift toward a possibility that blurs the line between reality and illusion, where the cosmos itself may be a construct, not of matter, but of information. What if everything you see, the stars flickering in the night sky, the weight of your body against the mattress, the quiet rhythm of your breath, even the thoughts forming in your mind right now, was not the product of atoms and evolution, but lines of code in a vast, unfathomable cosmic computer? Not a machine like the one in your pocket, but a simulation so advanced, so perfectly rendered, that it is indistinguishable from what we call reality. This is not the plot of a science fiction film whispered in dark theaters. It is a serious philosophical proposition, one that has found its way into academic journals, late-night debates among physicists, and the quiet corners of existential contemplation. The idea that our universe might be a simulation is not just provocative, it forces us to confront the very nature of existence, perception, and what it means to be real. The foundation of this idea was laid in 2003 by philosopher Nick Bostrom, who proposed what is now known as the simulation argument. He suggested that at least one of three statements is likely true. First, civilizations like ours rarely survive long enough to become technologically advanced. Second, even if they do, they have no interest in running vast ancestor simulations, detailed recreations of their past. Or third, we are almost certainly living in a simulation. The logic is subtle but compelling. If a civilization ever reaches a level of technology where it can simulate conscious minds, entire universes with beings who believe they are real, then it could, in theory, run thousands, millions, or even billions of such simulations. Each of those simulated worlds could contain beings just like us, asking the same questions, feeling the same emotions, unaware they are part of a program. And if that happens, then the number of simulated minds would vastly outnumber the original, biological ones. So statistically, if such simulations exist, the odds are that we are in one. This is not proof, of course, but a probabilistic argument that unsettles our assumptions. And yet, the more we learn about the universe, the more it seems to behave like a system built on rules, mathematical, precise, almost digital in nature. The laws of physics are written in equations. Quantum mechanics reveals a world where particles exist in discrete states, where energy comes in packets, where observation affects outcome, behaviors that eerily resemble the pixelation and rendering limits of a computer program. Some physicists have even pointed to the speed of light as a possible processing speed limit, the Planck length as a minimum resolution, and the apparent quantization of spacetime as evidence of a fundamental code underlying reality. It's as if the universe is not continuous, but granular, like a high-resolution image that, upon close inspection, reveals its underlying grid. But what would it mean if we are in a simulation? Who are the simulators? Are they future humans, running detailed recreations of their ancestors to study history or satisfy curiosity? Are they an alien civilization, so advanced that creating entire universes is as simple as we design video games? Or could it be something stranger, a recursive nesting of simulations, each one running within another, like dreams within dreams, with no original reality to anchor them? And if we are simulated, is there a way to break free? Could we ever detect a glitch, a pattern in cosmic radiation that looks suspiciously like an artifact, a repeated sequence in the background noise of the universe that hints at underlying code? Some have suggested that if the simulation has limits, We might find them in the behavior of ultra-high-energy cosmic rays or anomalies in quantum entanglement. But so far, no such evidence has emerged, only silence, and the uncanny precision of physical law. Then comes the darker possibility that the simulation could be turned off. That at any moment, the entire cosmos, your memories, your loved ones, the stars above, could simply cease. Not with a bang, not with a whimper, but with the quiet click of a power switch. The thought is terrifying, but also strangely irrelevant. Because if the simulation is seamless, if your consciousness is part of the code, then you would never experience the end. There would be no warning, no final thought, just non-existence, as sudden and complete as the closing of a file. And yet, even if this is all an illusion, does it matter? As you lie there, listening, feeling the weight of your body, the warmth beneath the blanket, the soft hum of the world outside, ask yourself, does it matter if this is real? If your feelings, your thoughts, your love, however they arise, are experienced as real, are they not real enough? Pain still hurts. Joy still lifts the heart. A sunset still takes your breath away, whether it's rendered in photons or pixels. The philosopher Alan Watts once said, "The only way to make sense out of change is to plunge into it, move with it, and join the dance." Perhaps reality is not defined by its substrate, but by its depth of experience. A dream can be just as meaningful as a waking moment. A story can hold truth even if it's fictional. Pause for a moment. Let your mind soften. Imagine that somewhere, in a lab or a server farm beyond our comprehension, a being, biological, mechanical, or something in between, is observing this simulation, watching you read these words, wondering if you'll ever suspect the truth. Or perhaps no one is watching at all. Perhaps the simulation runs on its own, a self-sustaining universe of code, evolving without purpose, without observer. Either way, here you are. Alive. Aware. Wondering. And if the universe is a simulation, then so is everything we can't see, the invisible forces shaping galaxies, the dark matter holding stars together, the mysterious energy accelerating the expansion of space. Perhaps the greatest mysteries are not hidden because they are too vast, but because they are deliberately obscured, like background processes running silently in the system, unseen by the characters in the simulation. Speaking of what we can't see, most of the universe is hidden in plain sight, cloaked in darkness we barely understand. Look up at the night sky. Let your gaze drift across the velvet black, dotted with stars, faint, distant suns, some long dead, their light still traveling across the void to reach your eyes. Trace the arc of the Milky Way, a river of ancient starlight cutting through the darkness. Every point of light, every spiral galaxy captured in deep space photographs, every planet, comet, and dust cloud we've ever observed, everything visible to every telescope, every eye, every instrument ever built, makes up less than 5% of the universe. That is not a typo. Less than 5%. The rest, over 95% of all that exists, is invisible. Not hidden behind clouds or obscured by distance, but fundamentally undetectable by light. We are floating in an ocean of darkness, surrounded by forces we cannot see, do not understand, and may never fully grasp. This is the quiet revelation of modern cosmology. We are blind to almost everything. The largest portion of this unseen cosmos is dark energy, a mysterious presence that permeates all of space and is causing the universe to expand at an accelerating rate. For decades, scientists assumed gravity would eventually slow the expansion set in motion by the Big Bang. But in the late 1990s, observations of distant supernovae revealed something astonishing. The expansion is not slowing down. It is speeding up. Galaxies are flying apart faster and faster, as if some invisible force is pushing space itself outward. This force is dark energy. It doesn't clump, doesn't attract, doesn't interact with light or matter in any way we can directly observe. It simply is. And it makes up about 68% of the total energy content of the universe. If the cosmos were a book, dark energy would be the invisible ink filling most of its pages, present, powerful, but entirely illegible. Then there is dark matter, another unseen player, making up about 27% of the universe. Unlike dark energy, dark matter exerts gravity. It pulls, rather than pushes. We know it exists because galaxies rotate in ways that shouldn't be possible. Stars on the outer edges of spiral galaxies move just as fast as those near the center, defying the laws of gravity as we understand them. There isn't enough visible mass to hold these galaxies together. They should be flinging themselves apart. But they don't. Something invisible is providing the extra gravitational glue. That something is dark matter. It surrounds galaxies in vast halos, shaping their structure, guiding the motion of stars, and seeding the formation of cosmic webs across the universe. Yet despite decades of searching, we have never detected a single particle of it. It does not emit, absorb, or reflect light. It passes through ordinary matter like a ghost through a wall. We feel its presence, like the wind on our skin, but we never see the sky that moves it. Together, dark matter and dark energy compose the vast, silent majority of reality. The stars, the planets, the people, the poetry, the cities, the memories, everything tangible, everything luminous, everything we've ever known or loved, is just a faint shimmer on the surface of a much deeper, darker ocean. We are like fish swimming in a vast, unseen current, sensing only the ripples it creates on the surface. We map the stars, chart the galaxies, and write equations for the cosmos, but we do so while blindfolded, inferring the shape of the world from shadows and echoes. This realization is profoundly humbling. For centuries, science has been a story of increasing clarity, of peeling back layers of mystery to reveal the mechanisms beneath. But dark matter and dark energy do not yield to this narrative. They resist. They remain just out of reach, like whispers in a language we cannot translate. And they force us to confront a difficult truth: science may never explain everything. There may be aspects of reality that lie beyond our senses, beyond our instruments, beyond our mathematics. Not because we aren't smart enough, but because the universe may not be designed for us to understand. We evolved to survive on a small planet, tracking movement in the grass and reading faces in the firelight. We were not built to perceive the scaffolding of space-time or the substance of the void. Feel the weight of the unknown. The darkness around you isn't empty. It's full of secrets, forces that bend the trajectory of galaxies, that stretch the fabric of space, that shaped the cosmos long before stars ignited. They are silent, patient, omnipresent. They do not announce themselves. They simply pull. And in their silence, they remind us that wonder is not the beginning of knowledge, but often its end. We do not need to know everything to be awed. We do not need to see something to feel its presence. And if most of reality is unseen, perhaps consciousness itself is a kind of dark energy, emerging from the brain, shaped by neurons and chemistry, yet not fully explained by them. Like dark matter, it influences everything, holds our experience together, gives structure to our inner world. And yet, we cannot touch it, measure it directly, or locate its source. It, too, may be one of the universe's invisible forces, felt deeply, known intimately, but ultimately mysterious. As you rest here, drifting between wakefulness and sleep, consider this: the mind that wonders about the cosmos may itself be made of the same unseen stuff that shapes it. And just as the universe expands in silence, so too does awareness, quiet, boundless, and full of unseen light. You are aware. Right now, as these words pass through your mind, you are experiencing the world, not just perceiving it, but feeling it. The weight of your body against the surface beneath you, the faint hum of the room, the quiet rhythm of your breath. You are thinking, remembering, wondering. There is a sense of I behind it all, a presence, a watcher, a center of experience. But where exactly is that you located? Is it in your brain, nestled somewhere behind your eyes? Is it in the thalamus, the prefrontal cortex, the synapses firing in intricate patterns? Or could it be that consciousness has no location at all, that the self you feel so intimately is not a thing, not a place, but something far more elusive? For centuries, we've assumed that the mind must reside in the brain, just as the heart pumps blood or the liver filters toxins. And indeed, neuroscience has made astonishing progress in mapping the brain's activity. We can see which regions light up when you recognize a face, recall a memory, or feel pain. We can observe the electrical storms of neurons firing in complex networks, synchronized like dancers in a vast, invisible ballet. But despite all this, no one has ever found the seat of consciousness. There is no single region, no neural command center where you reside. Damage to certain areas can alter awareness, yes, but consciousness itself doesn't seem to live in any one place. It appears to emerge from the whole system, like a symphony arising not from a single instrument, but from the harmonious interplay of many. And yet, even this metaphor falls short. A symphony can be recorded, replayed, dissected. But subjective experience, the redness of red, the ache of longing, the quiet joy of stillness, cannot be captured by data alone. This is what philosophers call the hard problem of consciousness. How do physical processes in the brain give rise to inner experience? How does a network of neurons, no matter how complex, produce the feeling of being? We can describe the wavelength of light that corresponds to the color blue, map the neural pathways that process it, even predict how you'll react to it, but none of that explains why you see blue, why it feels a certain way to you. The gap between objective measurement and subjective sensation remains unbridged. It's as if the universe has a secret it refuses to tell. And this leads to a radical possibility. What if consciousness is not something the brain produces, but something it tunes into, like a radio receiving a signal from a station we can't see? Some theories, like panpsychism, suggest that consciousness might be a fundamental property of the universe, as basic as mass or charge. In this view, even elementary particles possess a rudimentary form of experience, not thought, not emotion, but a faint glimmer of subjectivity. As complexity increases, so too does the richness of experience. A rock has almost none. A bee has a flicker. A human has a flood. But the capacity for awareness is woven into the fabric of reality itself. If true, then consciousness isn't confined to brains at all. It's everywhere, diffuse, subtle, latent in the very structure of things. Others go further, suggesting that consciousness might be primary, that the universe is not made of matter that somehow generates mind, but of mind that manifests as matter. In this idealist view, reality is fundamentally experiential, and the physical world is a projection of consciousness, not the other way around. It's a perspective echoed in certain Eastern philosophies and mystical traditions, where the self is seen not as a fixed entity, but as a ripple in an infinite ocean of awareness. Then there are those who argue that consciousness is an illusion, a story the brain tells itself to make sense of its own processes. According to this view, there is no you watching the show. There is only the show. The feeling of being a self is a useful fiction, a narrative constructed by the brain to create coherence in a chaotic stream of sensations and memories. But if consciousness is an illusion, then who is being fooled? Who is the I that notices the illusion? The moment you ask that question, the illusion begins to unravel. The deeper you look, the more the self begins to dissolve, like mist in the morning light, like a reflection fading from a still pond. Notice your thoughts drifting. One moment you're reading these words, the next you're remembering a childhood summer, then worrying about tomorrow, then noticing the sound of a distant car. Who is watching them? Is it another thought? A hidden observer? Or is there only the flow itself, no watcher, no watched, just awareness happening? Try to locate the part of you that is aware. Is it in your head? Behind your eyes? In your chest? The moment you search for it, it slips away. It cannot be pinned down, because it is not an object. It is the space in which objects appear. Pause for a moment. Let your breath slow. Feel the silence between thoughts. In that stillness, ask yourself, who am I, when I'm not thinking about who I am? Not the name, not the memories, not the roles you play, but the awareness beneath it all. Is it inside you? Or are you inside it? And if the self is not a fixed point, but a process, a pattern, a fleeting constellation of experience, then what does that say about the future? If there is no stable you to carry forward, then time itself may not be a line we travel, but a field we inhabit. And if time is not what we think, then perhaps the future is not ahead of us, but already here, waiting to be discovered. Let us now drift toward the next mystery, the possibility that time travel is not only possible, but paradoxically inevitable. We all travel through time, 1 second per second, into the future. It's so natural, so constant, that we hardly notice it. The clock ticks, the seasons turn, your body ages. This is time as we live it, linear, irreversible, moving forward like a river carrying us toward an unseen shore. But what if we could leap? Not just drift, but jump, skip ahead, loop back, step sideways into a moment that hasn't happened yet or has already passed. What if time travel isn't a fantasy reserved for science fiction, but something that might already be happening, woven into the very structure of space-time, hidden in the folds of gravity and the curvature of the cosmos? Einstein's theory of general relativity, the same framework that describes black holes and the expanding universe, allows for something extraordinary, closed time-like curves. These are paths through space-time that loop back on themselves, like a trail that circles back to its starting point. If such a path exists, then an object, or a person, could follow it and return not just to the same place, but to the same moment in time. You wouldn't need a machine with flashing lights and roaring engines. You'd simply follow the natural geometry of the universe, like a leaf carried along a swirling eddy in a stream. In this way, time travel wouldn't be an act of technology, but a consequence of how spacetime itself is shaped. One of the most famous theoretical gateways to such journeys is the wormhole, a hypothetical tunnel connecting distant regions of space, or even different moments in time. Imagine spacetime as a sheet of paper. If you fold it so two distant points touch, a wormhole would be a shortcut piercing through the fold. Now, if one end of the wormhole is moved at near light speed or placed in a strong gravitational field, time dilation would cause it to age more slowly than the other end. Step into the older mouth, and you might emerge from the younger one, into the past. In theory, such a setup could allow travel backward in time, not by breaking the laws of physics, but by bending them gently, like a skilled sculptor shaping clay. Even more exotic possibilities exist. Cosmic strings, hypothetical remnants from the early universe, thinner than atoms but denser than stars, could warp spacetime so severely that looping around them might send you back in time. Two such strings moving past each other at incredible speed could create a region where time closes in on itself. These are not proven realities, but mathematical possibilities within the equations that describe our universe. And while we have no evidence that such structures exist, their mere plausibility forces us to reconsider what time truly is. But then come the paradoxes, the mind-bending contradictions that make time travel feel impossible. The most famous is the grandfather paradox. What if you traveled back in time and prevented your own birth? If you were never born, how could you have existed to go back and commit the act? It's a logical knot, a loop with no beginning. Yet physicists have offered ways to untangle it. One idea is that the universe self-corrects. No matter what you try, events conspire to prevent contradictions. You might pull the trigger, but the gun jams. You might warn your younger self, but they don't believe you. The timeline protects itself, like a river flowing around a stone. Your attempt to change the past becomes part of what always happened. Another possibility is even more radical, that every action, every decision in a time traveler's journey, spawns a new branch of reality. In this multiverse model, when you go back and alter the past, you don't change your timeline, you create a new one. In that new universe, you were never born, but in your original world, history remains untouched. You are not erased, you are simply a visitor from another branch, a ghost from a timeline that still exists elsewhere. In this view, time travel doesn't break causality, it reveals that causality is far stranger than we thought. Cause and effect don't always flow in a straight line. They can split, diverge, loop, and coexist. And here's the most unsettling thought: time travel might already be happening, not in a visible, dramatic way, but silently, subtly, in ways we can't detect. If closed time-like curves exist at the quantum level, perhaps particles are constantly looping through time, influencing their own past. Some interpretations of quantum mechanics suggest that particles don't move forward in time so much as exist across time, their behavior shaped by future as well as past events. Experiments with delayed choice setups show that a decision made now can appear to affect what a particle already did in the past. It's as if time, at the smallest scales, is not a river but a web, interconnected, bidirectional, fluid. Imagine, for a moment, that you are not just moving forward in time, but leaving ripples behind you, echoes that fold back, that touch moments before your birth, that whisper into the ears of your ancestors. Or imagine a version of you, just a fraction of a second out of phase, making a different choice, saying yes instead of no, turning left instead of right. Are they more real? Less real? Or are they simply possible, existing in a parallel stream of time, just as vivid, just as valid, just as unaware of you as you are of them? Pause for reflection. Let your breath slow. Feel the stillness of the room, the quiet hum of the night. Now imagine that somewhere, in the folds of space-time, another version of you is reading these same words, but in reverse. Or that a future you is already remembering this exact moment, looking back with a quiet knowing. Time may not be a straight line. It may be a vast, branching forest, and we are only aware of the path beneath our feet. And if multiple timelines exist, if every choice creates a new universe, then perhaps every possibility plays out somewhere, in a vast, branching multiverse, where all that can happen, does happen. Every decision you've ever made, to turn left instead of right, to speak up in a moment of silence, to stay or to go, to love or to walk away, might have done something far more profound than simply shape your life. It might have split the universe. Not in a dramatic, visible way, but quietly, seamlessly, like a stream dividing around a stone, each path carrying forward a different version of reality. In one world, you took the job abroad and learned to speak a new language under foreign skies. In another, you stayed, built a home, and watched the same trees grow in your backyard for decades. In yet another, You never met the person who changed your life. And in one so distant it feels like myth, you never existed at all. This is not fantasy. It is a serious interpretation of quantum mechanics known as the many worlds interpretation, and it suggests that you, your thoughts, your choices, your very being, are endlessly replicated across an infinite multiverse. The idea emerged from one of the most puzzling aspects of quantum physics, superposition. At the subatomic level, particles don't exist in a single, definite state until they are observed. An electron, for example, can be spinning both up and down at the same time until a measurement forces it to choose. But what if it never actually chooses? What if, instead, both outcomes happen, just in separate, parallel branches of reality? This is the core of the many worlds theory, first proposed by physicist Hugh Everett in the 1950s. He suggested that the universe doesn't collapse into one outcome when observed. Instead, it splits. Every quantum possibility, a photon going left or right, a radioactive atom decaying or not, gives rise to a new timeline. And since quantum events happen constantly, everywhere, trillions upon trillions of times per second, the universe is branching endlessly, creating an unfathomable web of realities. You are not just living one life. You are living all possible lives. There is a version of you who became an astronaut, floating above Earth in silent awe. One who became a musician, fingers dancing across strings in a dimly lit club. One who never left childhood, lost to an accident that didn't happen in this world. One who speaks with a different accent, believes in a different God, loves someone you've never met. There are worlds where humanity never rose, where dinosaurs still rule, where Earth never formed at all. There are universes where the laws of physics are slightly different, where gravity is weaker, where light travels slower, where consciousness evolved in the oceans of gas giants. And in some, you don't exist, but something else, shaped by the same cosmic forces, does. This idea is both exhilarating and deeply disorienting. On one hand, it offers a kind of immortality. No choice is final. No path is lost. Every regret, every what if, is answered somewhere in the multiverse. The life you didn't live is still being lived, by another version of you. You are free, in this view, not because you can do anything, but because everything is being done. The weight of decision lifts, replaced by a quiet wonder. It doesn't matter which path you take, because all paths are taken. But on the other hand, it can feel isolating. If every possibility exists, then nothing is unique. No achievement is singular. No suffering is rare. The version of you who climbed Everest and the one who never left bed are equally real. Does that diminish the meaning of effort? Does it erase the value of choice? Or does it, paradoxically, deepen it? Because even if all versions exist, this version, this consciousness, this breath, this moment of stillness, is the one experiencing now. You are not all of them. You are just this one. And that makes your experience precious, not in spite of the infinite, but because of it. Imagine, as you lie here, drifting towards sleep, the countless versions of yourself scattered across the multiverse. Some are awake, reading these same words. Some are laughing. Some are crying. Some are already asleep, dreaming of a world where they chose differently. They do not know you. You do not know them. The branches do not touch. There is no signal between worlds, no way to cross over. And yet, in a strange way, they are all you, fragments of a self so vast it cannot be contained in a single timeline. Pause for reflection. Let your breath slow. Feel the weight of your body, the warmth of the blanket, the quiet hum of the night. Now imagine that in another universe, A version of you is feeling exactly this, but it's morning. Or it's raining. Or they made a different choice years ago, and this moment is completely different. And yet, in some deep, inexplicable way, there is continuity. A thread. A spark. A sense of being that persists across the infinite. And if reality is infinite, if every possibility plays out somewhere, then perhaps even the universe itself had no beginning, or will have no end. Maybe time doesn't start with a bang, but echoes through eternity, folding back on itself in cycles beyond comprehension. Let's now drift toward the final mystery, the eternal cosmos, where time has no origin, and existence simply is. We're told the universe began with the Big Bang, 13.8 billion years ago. In a flash of heat and light, space and time erupted into existence. It's a story so widely repeated it feels like truth etched in stone. There was nothing, then there was everything. But what if that's not the full picture? What if the Big Bang wasn't the beginning at all? What if it wasn't a creation from nothing, but merely a transition, a cosmic rebirth, a phase change in an existence that has always been? What if time didn't start? What if it never had a starting point, and never will have an end? What if the universe is not a story with a beginning, middle, and end, but an eternal cycle, turning in silence, without origin or finale? This is not mere speculation. Some of the most compelling cosmological models suggest that our universe may be part of an infinite sequence of cosmic epochs. One such idea is the cyclic universe model, where the cosmos expands, cools, and eventually collapses back into a dense state, only to bounce again in another Big Bang, restarting the cycle. Like a great cosmic breath, the universe inhales into contraction and exhales into expansion, over and over, perhaps forever. There is no first breath. There is no last. Just an endless rhythm of creation and dissolution, galaxies forming and fading like waves on an eternal shore. Even more radical is Roger Penrose's theory of conformal cyclic cosmology. He proposes that our universe will continue expanding forever, growing colder and darker as stars burn out and black holes evaporate. Eventually, all matter will decay, and the universe will become a vast, empty sea of low-energy particles. In this far future, Penrose argues, the universe loses all sense of scale, no distances, no masses, no time as we know it. It becomes indistinguishable from the hot, dense, featureless state of the Big Bang. At that point, the end of one universe becomes the beginning of the next. Not through collision or explosion, but through a smooth, mathematical transformation, a seamless handoff from one aeon to the next. In this view, our Big Bang was not the start of time, but the echo of a previous cosmos dissolving into eternity. If true, then the universe has no beginning. It simply is. And it always has been. There may have been infinite eons before ours, each with its own stars, its own laws subtly shifting, its own civilizations rising and vanishing into the void. And after our universe fades into darkness, another will emerge, perhaps with different constants, different dimensions, different forms of life we cannot imagine. The cycle continues, not because it must, but because it can. Because existence, in its deepest nature, refuses to end. This idea reshapes our understanding of time. We tend to think of it as linear, arrowing forward from birth to death, from past to future. But in an eternal universe, time is not a line. It is a loop, or a spiral, or perhaps a vast, unending plane where every moment exists in relation to others, with no privileged point called now. If the universe repeats, then everything that can happen, will happen, not once, but infinitely. Stars will ignite and die, planets will form, life will evolve, minds will wonder, love will bloom, and all of it will vanish, only to return again, in a different form, in a different aeon. You may have lived before. You may live again. Not as reincarnation, but as inevitability. In an infinite timeline, every possible configuration of matter must recur. the same choices, the same joys, the same quiet moments before sleep. They will all happen once more, and again, and again. And yet, in this endless cycle, our lives are not diminished. They are not meaningless because they repeat. If anything, they are more precious. Because this moment, this breath, this stillness, this awareness is real. It is happening. It is not just a recurrence. It is now. The fact that stars will burn out, that Earth will crumble, that all memory of us will fade into cosmic silence, that does not erase the truth of this instant. You are here. You are feeling. You are wondering. And that matters, not because it lasts forever, but because it exists at all. Let this thought linger, that long after you're gone, and Earth is dust, and stars have burned out, and even black holes have evaporated into faint whispers of radiation, the universe may still be turning, quietly, in the dark. Not with fanfare, not with purpose, but simply because it can. The cosmos does not mourn. It does not celebrate. It unfolds, indifferent and eternal, like a river that has no source and no sea. 10 mysteries. 10 doors into the unknown. From the edgeless universe to the illusion of time, from black holes that whisper to simulations that may contain us, from infinite selves to an eternal cycle of existence, we have wandered through the vast corridors of cosmic wonder. The universe doesn't give answers. It gives questions. And in their quiet echo, there is peace. You don't need to solve them. You don't need to understand. Just let them be. Let them drift through your mind like stars across the night sky, distant, beautiful, untouchable. You are small. You are part of something vast. And that's okay. You do not need to be the center. You do not need to be eternal. You only need to be here, now, aware, breathing, feeling the soft weight of the blanket, the hush of the room, the slow descent into sleep. Sleep now. The cosmos will keep turning, without you, and because of you.